So hello everyone, welcome to week 3 of ExCode. Heart goes out to all of you who are currently isolating, but there's no better time to do ExCode if you're locked indoors. So this week we are going to cover a few things, but in more detail because they're quite important. So the session might be slightly shorter and there'll be more exercises at the end. I've also recorded a recap of myself doing the exercises. So if you don't finish them in your tutorial groups, then you can just watch that. It's only like 15 to 20 minutes long. You can just pick out which ones you want to watch. And now just to get onto the content. Okay. There we go. Right. So let's do a quick recap of the things that we learned the other day. So the first thing we did was the comparison operators. So that's when we like compare things like larger than, equal to, smaller than or equal to. So let's just get some values down. Value 1, let's give it 65, and let's do value 2, and let's give it 67. So when you compare two things, it can come out as true or false. So if I were to compare 67 and want to check that if I want to check that value 1 is larger than value 2, I just do the value 1 is larger than value 2, and if I run that, obviously it's going to come back as false because value 1 is less than value 2. If it will load, the first one takes a while, we'll put false out, but if I do the other way around, is smaller than value 2, it will come back as true. Another test we can do is the equal to, so it's two equal signs, that's just is value 1 equal to value 2. Obviously in this case it's not, so it's going to come back as false. And then you can do the operator which is not equal to. So is value 1 not equal to value 2? In this case, that's going to be true because it's not equal to. What else did we do? We did slicing of strings. So as I said, let's just write a small string. So test string equals hello Exeter. And so a string is basically just loads of characters in order, and they can be accessed one by one. So if I just wanted to get the first letter, I'd access that by doing test string and then square brackets and then 0. If I print that out, that should just come out as H because each letter is corresponding to a little index. So the first letter is going to correspond to the 0 index. The second letter is going to correspond to the first index. So if I do test string 1, I'm going to get E. And then you can also use negative numbers. So I could do -1, and that will give me the last one, which is a dot. Or I could do -2, and that will give me the second last one, which is an R. So an index starts at 0 and makes its way to 1 less than the length of the string. And we also said you could do slicing with it, which is where you sort of take a segment out of a string. So you start with where you want to start the slice and then where you want to end it. So if I do 0 to 4, look like hell. If I do 0 to 5, I do hello. So what it does is it just takes a slice out of it from the 0 index, which is H, up until the 5th index, but not including the 5th index. So in this case, it goes from 0, 1, 2, 3, and 4. So hello. And you can do it negatively as well. So I do -6. And if you leave one of the numbers blank when you have a colon there, it just assumes it's going to the end. So in this case, that's just going to give us, didn't count properly, Exeter. That's just going to give us from the second last one to the end of the string. Okay. And sort of the same thing applies to lists, where a list is just an ordered set of values. So if I were to do a test list, this is how you create a list, just do square brackets and then do 23, 45, 65, 87. But list can be any kind of variable. So it can be a float or it can be a string. So a list is simply an ordered set of values. It can be anything. And you can add things to a list by doing test list dot append and then put 45 at the end, for instance. And that will simply just add whatever's in the brackets to the end of it. So now if I print out test list, it will should have 45 at the end. Yeah. And just like a list, if I want to access any part of the list, I just have to put its index in. So I'll look for the third one. So that should be 87. Yeah, 87. And on top of that, we want to maybe delete something from a list. So if you want to remove something from a list, you just say del, stands for delete, and then list, and then its index. So if I want to delete the first one, that should delete the first one. I'll just print it to see if that was right. Yeah, so it's deleted the first one, first index from the list. So that's going to be 23, and it's just moved everything back along. There's that. What else? You can also overwrite things in lists. So if I wanted to overwrite this is the second one, you can basically just overwrite it by getting into the list on the second index, which is 65, and you can assign it a new value like 999. And when I print out the list, it will it should have replaced it with 999. Yeah. Okay, and then the next thing for lists was that you could loop through lists using a for loop. We're going to go in more detail through for loops today because they're quite important. So you should be able to, even if you weren't so sure about them last session, you should maybe have better understanding today. So for, in this case, you say for and then anything in test list. So do that. Right, basically this is for every value in test list. So it's what it does is it loops through the list and it applies something to every member in the list. So in this case, maybe I just want to print them out. Which I print them out of number plus 1. So if I do this, it should be all of the numbers in there. Oh, have I done wrong? Print not string. Number plus. What am I doing? It doesn't work because I'm trying to add +1 to a number. So sorry, let me just get rid of that. So that's just what it's done here is it's gone through every member in the list and just printed it out +1. Yeah, so what this is, a for loop is just simply everything that's indented is sort of repeated. Everything indented is repeated for every single member in the list. I had a couple of questions where people were wondering why I could use different things instead of a number. This is simply just like any other variable. So you can name it whatever you like. As long as you refer to it with its name, you'll get the same values. So I could put just the letter I, which is a lot of people do, and just replace it there, and it will act the exact same if I were to use value or I or number. It's just a placeholder basically every time you loop through it. So as long as you sort of keep it uniform, it doesn't matter what you put there, as long as it sort of abides by the usual rules of making a variable. Okay, so that should be everything there. Right, now if and else's. You might be sort of wondering where we use conditionals. We learned last time where it's like, the comparison and getting true or false. Well, this is where they're predominantly used in conditional statements. So basically what this does is it sort of segments code into like a block. And if something is true, it runs that block. And if it's not true, then it's false, then something else is run. So I'll just give an example of this. So we've got the first number, which is 3.4, and the second number, which is 64. Say we want to run a piece of code if first number is larger than the second number, but run a different piece of code if the second number is larger than the first number. So I'll just quickly give an example. So if first number is smaller than second number. Okay, so I'll just put something here. Okay, so the way you read this is just reading like in plain English to get the sort of logic behind it. So what's happening here is I'm saying if first number, which is here 3.4, is smaller than second number, then run this piece of code. So in this case, first number is smaller than the second number. So this sort of this translates to true because you've compared it in there, it comes back as true. And so it says, if this is true, then print this out. So in this case, if I were to print this out, this number is smaller. What it's done is it only runs that code if the first number is smaller than the second number. So if I were to change 3.4, let's just say I put that as 100. Now in this case, first number is 100, second number is 64. Obviously 100 is not smaller than 64. So this, works out to be false. Now if I run it, nothing pops up because this is turned out as false. So it's not run. So it just checks the conditional, and if it's true or false, if it's true, it runs it. If it's false, it doesn't run it. Now, as an extension to that, if you make a comparison like this, and if it's true, you run something, but there's also the possibility that if it's false, you can also run something. So that uses the keyword else. So in this case, let's just go back to that being 3.4. And I say print this number not smaller. You run this again. Obviously 3.4 is smaller than the second number once again, so it runs that. But once again, if I change this now to 100 and I run it, this number is not smaller. I've now run this. So if this turns out to be false, then this is run instead. So it's basically, if this is true, run this, else run this. The best way to really think of it and sort of put it through your head is just to say it, because it's that simple. It's quite close to being like a natural language. What else could be there? Also, now there's a way of, say you want to compare multiple things in one go. So say you want to check that the first number is smaller than the second number, but you also want to check that it's bigger than the third number. So let's just put this to 50 and this to 24. So you can connect two conditionals together using a keyword and. So if I said where I will check that it is larger than third number. So basically what I'm doing here is I'm saying if first number is smaller than the second number, so it's 50 smaller than 60, which is true, and the first number is larger than the third number. So what I'm saying is I need this to be true and this to be true in order for the whole thing to be true. So in this case, it is true because first number is obviously larger than the third number, so 50 is larger than 24. So this is just connecting two conditionals together. So the whole thing basically goes, if you read it out in your head, it's just if the first number is smaller than the second number and the first number is larger than the third number, then do this. Otherwise, do this. So as you can see, like we're using for loops, everything afterwards that you want to be run, if it's true, is indented with a tab. And then once you've sort of decided that you don't want anything to be completed afterwards, you just unindent it using a backspace. And then you can write the else statement again, which also needs to be indented. Okay. There's also, alongside and, there is also something called or. Now, let's just, so in this case, let's put 90. So if I run this, I'll just change that, it's not the correct description. Okay, so let's say I put 90 here, at which case this is going to be false. So obviously I need both of these to be true in order for it to run this piece of code. Now I've changed it to 90. So if I run that, obviously it will say false now because, as I said, both of them need to be true in this case. The first one's not true because 90 is larger than 64. but I can use, instead of an and keyword, you can use the or keyword, which means that only one of them has to be true in order for the whole thing to be true. So if I use or, it'll come back as true, because the second one is still true, because 90 is still larger than 24. So there's two ways of connecting conditionals. You can have them as being and or. So and is that they both have to be true, or is that only one of them have to be true. I'll use more examples of if statements as we go along, but yeah, let's just move on to more for loops. So we've already done for loops when we loop through lists, but there are a couple other things you can do with it. So firstly, let's do this one. So for number in. So say you don't actually have a list, but you want to use a for loop a certain amount of times. You want to do something, do a math equation, or just analyze something a certain number of times. There's a way of sort of doing that without actually having a list. So for number in, so range, and then 0 to 100, let's do 50, 1. Okay, so what this is doing is it's saying for number in range. Now, you can think of this as exactly like it was previously, where it's like for number in and then the list, at which point you'd be going through the list one by one. What this is basically doing is it's sort of creating its own list that has the values 0 to 50. So what this is doing is it's basically, it'll go through, so actually it's probably easier if I just show you how this works. So just print number. So for number in range 0 to 11, what it's doing is it's setting the first value in this for loop to 0, the second one to 1, the third one to 2, the fourth one to 4, and it's just looping through them. So this is exactly like if you were looping through a list, as we've previously done, but this time we're just basically creating the list right there, right in front of it, starting at 0 and then going up by 1 each time up to, but not including 11. So in this case, it's 0 to 10. And yeah, it's just basically creating a temporary list just there and then. This can come in useful if you just want to check something or iterate over something like a certain number of times. Okay. You can also use if statements inside for statements. So I'll just quickly give an example. So if you want to have, say someone supplies you with a, well, you go into uni and you just like tap your card on the card reader, your uni ID, and it will allow you into certain rooms. So you need to sort of check the database if you've got, if your student ID is on the database. So there's a simple way of doing this in program. This is obviously not how they do it, but it's roughly the same. So you've got the customer ID here provided, 5515. So what you want to do is first of all, you want to like loop through all the IDs and then check if any of them is equal to the customer ID that's currently just being presented. So if I go for ID, I'll call it an ID, in ID numbers. So I'm just going to loop through ID numbers. And I can use an if statement here. So I can say if the current ID of this loop equals customer ID, then run this. So what I'm doing is I'm looping through every single one. And if the ID if any of those ones is equal to the customer ID, then I'll run this if statement. As you can see, it's also indented again. So I've indented once for the if statement. I'm going to indent again. For the for statement, I'm going to indent again for the if statement. Now I can just print the customer ID has been found. Okay. so that once it does find, so it will quickly just go through here. Once it arrives at 5.5, once ID has been assigned 5515, sorry, then it will run this if statement and then run this piece of code. So if I do this now, let me just get rid of that so it doesn't print again. The customer ID has been found, obviously, because 5515 is inside here. So once again, I'm basically just looping through the list, assigning ID every number, and then once I've come across this, it will print it out. So the next thing you might wonder is that even though I found the customer ID, it's still going to continue looping through this continuously, even though it doesn't need to, even though it's found the customer ID. So there's no point of it to continue looping through here, because that's sort of inefficient and there's just no reason to do it. So there's something called a break. And when you use the keyword break, what it does is that it simply just exits the loop that it's in and just goes to the end of it. So I'll just do this as a placeholder. So what's happening here is I found if statement, and I found that this is 5515 is inside there. I print this out and then I run the keyword break. And what this does is it just goes, okay, we don't need this for loop anymore. And it just goes, exits the for loop and we continue down the program. There we go. So I'll just do that quickly as another thing. So if I don't have the break statement there, it's sort of, as you can see, every time I run the for loop, I print counter out. So what happens is if I don't have the break there, it continues looping through. But if I put the break there and run it again, this time it doesn't continue the for loop. It sort of exits right there once it's got the thing that it needs. Yeah, that's that. So you can use if statements inside inside your program. Also, you might have noticed that I didn't use an else statement here. You don't always need to use an else statement. Yeah, you don't always have to use one. They just come together. An else statement, you need an if for an else statement, but you don't need an else for every if. Okay. Now, moving on to another kind of loop. So a for loop, you sort of require a list to work through, but there are ways of creating loops that don't need a list and basically just go off conditionals, like comparing things. So that's called a while loop. So what this means is while, and then it's just a statement of while something is true, continue looping through something. So I've been given like a count at 0. And I'll do basically the exact same thing that was done on the for loop up here, where I used range to go from 0 to 9, but using a while loop. So let's do while counter is larger than, while counter is smaller than 10. Okay, so what I'm saying is, this is once again a loop. So what I'm saying is continue looping through the code that I'm about to write until this isn't true. So until counter is smaller, like larger than 10. So basically in this case is whilst counter is smaller than 10, do this code. But when counter is larger than 10, don't do this code. So I'll just quickly, every time I run this code, I'll increase counter by 1. So just do that. I'll do print. This has run. I'll just run this out just to try and help explain it. So what I'm doing is while counter is smaller than 10, run this. So what it does in this code is every time I run it, I'm just printing out this is run, and each time I'm increasing counter by 1. So what's happening is I'm slowly increasing counter up until 10, and the second counter, once I've been increasing by 1, so every time I loop it, has reached the value 10, this will no longer be true. So it'll say, okay, this is no longer true. I'm now going to exit this loop and we're not going to run it. So this is why this is run 10 times, because I've had to add 1 10 times to 0 in order for it to reach 10. So maybe a better way of putting this is just going counter and then just the value for counter. So you see counter, I always go all the way to 9. I'm just adding 1, and then it gets to 10. It adds to, on the 10th loop, it adds 1 to it and gets to 10, goes all the way back to the start of the loop, tests this, finds out the counter is 10, and 10 is not smaller than 10. So this is false, and it stops running this while loop. So obviously you can do this the other way around. So I could just start off at 10 and say that I want to continue the loop until it hits 0. So in this case, I'm saying start off at 10, every single loop we're going to -1, and we're only going to quit the loop once it's, oh, sorry, I have done that wrong. Sorry, wrong way around, like that. Sorry, whilst counter is larger than 0, print does continue this loop. So it's basically, you're just saying, while something is true, do this loop, and then once it's finally false, the loop will stop. Now, one of the problems with this is if, as I did, I basically did the wrong inequality there. And that either means the loop won't run or the loop will run indefinitely. So for instance, let's say I don't actually do anything to counter. So what if I say counter's 10 and I say while counter is more than 0, but I don't change counter? It means this is going to run infinitely, because there's nowhere in here that that makes that go false. That's always true because I'm never ever changing counter. 10 is always more than 0. So there's a, if you sort of write your code wrong, it can either run infinitely or it can not run at all for a while loop. Okay. Once again, you can also use ifs inside here. So let's just do up until 10, and then let's print out all the odd numbers, so, or even numbers. So if I do start off at 0 and print all the numbers up to 15. So while counter is while counter is less than 15, and we'll just do as I did before, counter equals counter plus 1. So each time I run through the loop, I'm going to add 1 to counter. Now let's use a if statement in there. So if I'm going to quickly do introduce you to something called a modulus operator. So it's just another thing like a plus or a minus or a multiply. But what this does is it gets 2 numbers and it divides the first number by the second number, and then whatever remainder there is, it will return it. So for instance, if I were to do 5 divided by 3, so 3 goes into 5 once, but it's got a remainder of 2. So if I were to do that and put like 5 modulo 3, it would return 2. So I'll just quickly, I will quickly just do that just to show you how that works. So, so I have print, and I printed off 5 modulo 3. So what this is doing is it's dividing 5 by 3 and then returning the remainder. So it uses a percentage sign. So that's what the modular is. I could use 10 divided by 3 and then return the remainder. So it should come back with 1. Or I could do 10 divided by 2, which is 5 remainder 0. So it will come back as 0. This is simply just divides the first number by the second number and then returns whatever's left over. So this is really good if you're just trying to check for like even numbers or odd numbers. So I'll quickly do this. So if you want to test that something is odd, we basically want to divide it by 2, and if there's anything remainder, then it's an odd number. So I'll just do counter modulus and then 2. So every time I get a new number from counting up, so each time I'm going through 1 to 15, 1 to 14, sorry, 0 to 14, so just like a for loop using the counter. And what I'm going to do is I'm going to say does not equal 0. So what this is doing is it's saying if the current value of counter divided by 2 and its remainder does not equal 0, then do this line of code. So in this case, this is simply just going if the current value of counter is odd, then do this code. So in case this was like, let's say this was 3, 3 divided by 2, and the remainder is 1. So that will come down to 1. Does not equal 0. So obviously 1 does not equal 0. So this will be run. However, for instance, if I put 6 in there and it was 6 divided by 2, the remainder is 0. So that would end up being 0 does not equal 0. Obviously 0 does equal 0. So it will just like not run this code because this whole statement's not true. So if I do that and I do print counter, so if I do this, so what have I done? I have not got rid of this from the last program, my bad. There we go. Okay, so this is printing out all the odd numbers. So simply I'm just going through the while loop, adding each time 1 to counter, and it's just stopping when that comes false, which is when it becomes 15. So it goes all the way from 0 to 14. And then what it's saying is every time you go through the loop, test the remainder of counter, so of divided by 2. So for instance, you'd get an odd number, the remainder would be 1. And if you got an even number, the remainder would be 0. And then I'm saying if it equals 1, then don't do run this, and if it equals 0, don't run this. So that's simply there. So a while loop is simply while something is true, do this code, and then the second it becomes false, it no longer runs the code. Well, once the loop's finished, it no longer runs the code. Yeah, so that's that. I believe that should be everything that we are going over today. There's quite a few questions. There's 8 questions for the tutorials. Yes, and I've also recorded myself going through the questions just in case you don't cover them in your workshops or tutorials with your teaching assistants. Yeah, I understand this one might be a little bit more difficult, so it might take a little bit longer to go through everything because you know, these are quite challenging things to remember, but I'm pretty sure you probably will all get it by the end of today, hopefully. Okay, so thank you very much. We're probably gonna end this here, and you can go into your smaller like TA groups. Yeah, so thank you very much, everyone. Good luck with everything.